one turns out better. All right, here are the answers to the top half of the homework yesterday. Just like what we did when we went over it yesterday, I'm guessing if you did it, you got it correct. Do you guys just want to check or do you want me to say it out loud? So let me be quiet while you look?
Yeah.
Okay, sounds good to me. So just check your work. Those are the only answers. It's too much?
But you can't even get the end. Wait, if he wrote all the answers down, would you give him credit or not? Oh yeah, because it's completion.
Yep.
Oh, well.
Oh, well.
Did you not do it?
Why would?
I do drop your lowest homework grade. So Riker, if this is your only one you've missed, then you're okay.
Wait, so does that mean my last homework of the, wait, is it quarter? You dropped
One
it?
per quarter, I drop the lowest.
Oh, so I did not do one.
That's what that means, yes.
That fucked up.
Sweet.
What? That fucked up. Yeah.
Wait, is that what? Oh, but. Yo, that's on recording though.
Definitely took me a hot minute to figure out what he
I
was
like,
saying.
what?
Are there any up here that you don't understand or need me to explain where it came from?
No, I got them already.
I'm guessing, like I said, but you probably did because
No, it's got.
Miss-
Yeah,
He has no.
For the composition of gold.
you have what?
nothing. I didn't write it.
He was so confident. Ready? This is what happened. He came up to me in the hallway. Really? Did you know milk's the composition of gold?
Where are you getting your
That's worse than my first.
where are you getting your information from?
His brain in the hallway here.
It's
That's
So
why
you
did
had
you
a
not
dream
notice?
last night, and so for the record, that's not it.
Was I close? Was I close?
The composition of gold?
Yeah,
Yeah,
No.
it's diet gold.
Literally, the composition of gold,
is AU.
AU, which is just gold.
See, that's worse. than
Bro, I
mine.
had that, but like milk, it's like the same thing.
It's not, and also, why do you have, like, where are you putting this information?
Milk and butter.
There's nowhere on here.
It just happened.
Okay, all right, so nobody needs me to go through any of these. Okay. Moving on, the bubbles with acid when powdered, some people were putting calcite. It is not calcite, it is dolomite. Calcite doesn't have to be powdered. So then we have amphibole, halite, selenite, gypsum, hematite, talc, graphite, quartz. I should have told you that this part of the question, the polarizing prism, is no longer on the reference table. They took it off. But the calcite used in cement, so its uses for calcite is cement. So that's where that came from. Good on that one. Now the other side, I'm questioning this one. I think you guys actually had to think, and I'm wondering, hoping if you actually tried. So let's see. What is that thing, that structure called? I told you on Friday, it's just something you gotta memorize. That is a tetrahedron. This is the only way I've seen this question asked. It's the only shape they ever ask you about. So when you see that pyramid shape with 3 oxygens on the bottom, topped with like a cherry on top with a silicon, that is a tetrahedron. You just gotta memorize this. I have seen it like 3 times in my entire teaching career, but it is a standard. It is fair game for them to ask you. So just keep an eye on that one. Now, we did not get to this, but I'm curious if you know it. The grouping of rocks based on whether they're igneous, sedimentary, or metamorphic. What puts them into those groups? Did you guys know this answer? It is their origin, which, by the way, do you guys know what origin means? It's how they're created, how they began. Yeah, so where they came from, how they formed, however you want to think of that. So what do most igneous, sedimentary, and metamorphic rocks have in common then? Yeah, can I see a show of fingers for that one? Oh, I'm seeing a couple different answers. It is 3. They are composed of minerals. Question 4 is exactly the same as question 2. Again, that's origin. But now the rest of the questions, you should be able to answer these ones. And again, I want to see a show of fingers just to see how you guys are doing with this. When various minerals are split by a wedge, some break evenly along flat surfaces, while others fracture unevenly. What property of a mineral is responsible for the way it splits? All right, I am seeing the right answer. It is how the atoms are arranged. the internal arrangement of atoms. You got it. Which is the exact same question, just worded slightly different here. So answer number one for 6 is the answer there. Now, question 7, again, was kind of a thinking question more than an earth science question. So on Earth, there's more than 2,000 identified minerals. Only a small number are commonly found in rocks. This fact indicates that most what? Which answer did you pick? 1, 2, 3, or 4, please. Okay, 7. Okay, so I'm seeing a couple different answers. The answer is number 3. So that's saying that rocks have a number of minerals in common. So, question 5, question 6, and question 1. How'd you do on those 3? If you did okay on those 3, then you get everything we were supposed to have learned. I probably should have taught you for question 2 and 4. That I should have just waited until today's notes to give you this homework. But the reason I asked about question 1, 5, and 6 is because I'm not sure if you noticed on the board that we're going to have a mineral quiz on Thursday.
Yikes.
So just on minerals. So yes, questions 1, 5, and 6 are fair game. I will not ask you about question 2. I will not ask you about question 4 or 7. I guess I could ask you about number 3, though, that rocks are made of minerals. The rest of the test will be on like what your homework was on, being able to use the reference table, knowing about luster, cleavage, hardness, fracture, stuff like that. It'll just be a quick quiz. I actually won't be here. I have to go to the diving championships. So you guys will do the quiz, and then you will have some questions about the rocks that we're going to learn today and tomorrow. And then are you guys aware that you don't have school on Friday?
Yeah.
Okay, so I did break the news to some sad folks first period this morning. They weren't aware that you did not have school on Friday, and they were so sad. Well, because they wanted to come to school.
I don't want to come.
I was just joking. They were very happy I made their week. So today we're going to just start learning about rocks. Tomorrow we're going to go in depth a little bit about one type of rocks. Quiz on Thursday, some practice with rocks on Thursday. Then you have Friday, Saturday, and Sunday off. You'll have homework only if you don't finish what you were supposed to do in class. And then we'll start again with rocks on Monday and all next week. Okie doke. So we are going to start rocks on page, I don't even know what page it is. Looks like page 10. But to start this, you also need to grab your reference table and open it up to page 6, please.
Open the hard page out there on Thursday.
Quiz on page.
It's not right.
I'm so confused where that even came from.
In the hallway.
I had a dream last night. I was drinking milk and I was like a billionaire. So I guess I was like a billionaire.
No, your turtles is pretty pathetic as well. All right. Here's where we are. We are on page 6, upper right-hand corner. I need a blank one. No. Page 6 of our reference table is where we're going to be, and page 10 of our notes. We are focusing in on the rock cycle. So just this upper, what is that, left corner of page 6. You can see from page 6, there's actually 4 separate charts. The Regents used space wisely and gave you lots and lots of information on pages 6 and 7 about rocks. It is going to be really important that you get familiar with all 4 of those reference tables, and I will help make sure you're ready to use them. But we're going to start rocks by looking at the rock cycle. You've learned about cycles like since you were little kids. Any other cycles you've learned about?
The water cycle.
Water cycle. You learned about the nitrogen cycle? Oh, last year. I forget about living environment. I don't like living environment.
Hydrogen cycle.
Okay.
The human
What's,
cycle.
what's the deal with cycles?
They repeat.
They repeat. They go around and around and they happen over and over again. So the rock cycle's no different. So when you look at this, any words on here sound familiar at least?
Weathering.
Weathering sounds familiar. Magma sounds familiar.
Melting.
Melting, erosion.
Solidification.
Okay, how about the main words? How about igneous, metamorphic, and sedimentary? Have you at least heard those words?
Yeah. Yeah. Igneous, like,
Metamorphic
Igneous is like hot. Metamorphic,
is like
changing.
sediments are like erosion.
Yeah. So you got, sounds like a few of you remember some of this stuff from your earlier days, which is great because back in the day, you know, like elementary and middle school, you had to memorize all this stuff. I know my daughters, when they were in second grade, their second grade teacher taught them like a little dance about the different rock types. It was a little questionable.
We should learn that.
We should not learn that.
I'll do it. I'll do it.
Oh, I should talk to her, see how that, oh, then I can't. Anyway, let's keep going. Guys, focus.
Oh, locked in. Oh. Oh.
So
locked in.
Oh, crap.
back in the day, you had to memorize this. And that's great. But who actually cared? Okay, not many. A couple of you cared.
Sure.
Why they make you memorize it, I don't know, because then they give this to you, and I know many of you aren't going to care about this in your real life. So what I do care is that you can look at some weird looking charts, like this rock chart, and be able to read it. Because there might be things in your real life where you're handed a weird looking chart and you're told to figure out stuff from it. Or you might be told to, hey, can you make a chart to make this make sense to other people? So this is a time in science where, yes, I might technically be teaching you science, but I want you to be more comfortable using resources. So here we have a cycle chart. You see a bunch of things with arrows coming out of them or going into them. And I want to break this down. What does an arrow mean to you? So when there is an arrow, what kind of information can you gather from an arrow?
It goes to this.
Okay, so it tells you to go somewhere. So if I look at the head of the arrow, that's where you're headed. That's where you could go, right? What if you look at the butt of the arrow? That's where you started or where you came from. Almost like a timeline, that works. So let's add an arrow to the top of page 10. And I know this is goofy, but I want to make sure you guys truly understand. So first of all, are you guys all good with this being the head of the arrow? And this being the butt of the arrow? If we want to label that, go ahead. But I will refer to the heads and the butts of an arrow for a lot of times this school year. So make sure you realize that the head is the pointy part, the butt is the end, or I don't even know what to call it other than the butt of an arrow. What?
The badonkadonk.
Okay, moving on, now that you've made it weird. So when you're looking at arrows, again, the head of an arrow tells you where it's going. The butt of the arrow tells you where it started. Okay, I don't think that's rocket science there. Could be. In fact, actually, rockets probably have a bunch of arrows on them. Let's look at this chart and why I want to talk about the arrows. Let's take a look at, let's start with igneous because that's going to be the one we start today. If we look at igneous rocks, what do you notice about the arrows around it?
Magma has to be solidificated.
Okay, so we got one arrow coming into igneous and 3 coming out. So let's talk about the ones going out. We've got one here that's saying weathering and erosion turns into sediments. We've got one here that says heat and pressure metamorphism points to metamorphic rocks. Or we've got one coming out that says melting and points to magma. The 3 arrows coming out of igneous are telling you the three things that it could be or where it could go. So this reference table tells you where it could go or what it could turn into. Now let's read the arrow backward that's coming out of it. So if we look at igneous rock, not coming out of it, coming into it. There's one arrow coming into igneous rocks. If we read that one backwards, it points from magma and solidification. Hang on one second. There's nothing on here that says, we're on this chart here. Yeah, so let's stick with what we're learning now. The arrow coming that goes into igneous rock, again, if we read it backwards, says magma and solidification. What does that tell you about igneous rocks?
It comes from magma.
It comes from magma that has been solidified. So even though they made you memorize that, which might now be sounding familiar again, you had to memorize that when you were little kids. Here they give you a chart that you can read. This chart will tell you how all the different rock types form. So what do we need to put on these parts of our notes? So there it is, sorry. The rock cycle shows the continuing change from one rock type to another. So we can use this rock cycle chart to show how one rock type can change into another and another and another and another and forever and ever and ever. It also shows how they formed by reading it backwards. So we want to go through and we're going to describe how each of these rock types form. We actually already did igneous. So again, going from igneous, and if I asked you how it formed or where it came from, read it backwards. It comes from magma and it goes through solidification. By the way, do you guys know what solidification means? It solidifies, becomes solid. So that's what we're going to put right for igneous. It goes from magma or comes from magma that's solidified. Yep.
You know how people say magma is like a whole different thing of matter? Like they say liquid.
Plasma, I think.
Plasma.
Yeah. Let's do the same thing with sedimentary now. So find sedimentary. I always start by having people point to the word sedimentary. And how again do we figure out how a sedimentary rock forms? Read it backwards. So sedimentary come from sediments. Ooh, do you guys know what sediments are? Kind of. Sediments are broken rocks or broken pieces. So if you want to add that right to your reference table, you could. Broken pieces of rocks. Now, what happens to those broken pieces of rocks to become a sedimentary rock?
Deposition.
Deposition. Just checking. Do you guys know what that means? Deposition? No, it doesn't mean break off. It means deposited, which just means dropped off. So broken pieces of rocks get dropped off. So deposition. Do you guys understand burial? Do we need they get buried? How about compaction? Squished together. And then what about this word sedimentation? What's a word look like? Cement. So like Carson said, they harden, they get turned into a solid rock. So how do they form? Sedimentary form when sediments, they get deposited, buried, compacted, and sorry, the line's not quite long enough, cemented together. That got messy, sorry.
What's your favorite rock?
We're gonna keep going for right now. We're running short of time. And finally, metamorphic. How do I figure out how they form?
Follow the arrow backwards.
Follow the arrow backwards. And what does the arrows that are going into metamorphic say? They all say heat and or pressure. So again, this chart will tell you how they are all made. Looking at this chart, I ask you now, name the rock that comes directly from other rocks. What do I mean by directly, by the way? Straight from. Just like if I tell you to go directly to the office, I expect you to go to the office without making any stops, no bathroom breaks, no talking to your friends, all of that. Which one comes directly from other rocks without making a stop? No, magma's not a rock. The rocks are the 3 rock types.
Good question.
Yeah, metamorphic. Sedimentary rocks, give them just heat and pressure, they turn into metamorphic. Igneous rocks, give them heat and pressure, they turn into metamorphic. Even this arrow right here is showing give metamorphic rocks some more heat and pressure and they turn into a different metamorphic. The other rock types, to become an igneous rock, you have to make a pit stop at magma. To become sedimentary, you need to make a pit stop at sediments. Metamorphic is the only one without a pit stop.
So when it says metamorphic turns into another metamorphic, it just like means it changes the kind of rock, right?
Yep, it can start with one it's almost like, I kind of think of it a lot like toast, where you can put it in your toaster and give toast heat for a little bit, and it might turn into some light brown toast. But then if you give it some more heat and toast it again, it's going to turn into dark brown toast. And if you did it again, it's going to turn into black toast, correct? So it's similar to that concept, where it can get a little bit toasted or very toasted the amount of times you cook it. Let's keep going. Which rock comes from magma? Igneous. And what rocks come from sediments? That's a stretch, right? Sedimentary sediments. And finally, name 3 things that could happen to any rock. If you notice, every rock type has 3 arrows coming out of it. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3 things can happen to each and every rock. What are they? Every rock type can melt. Every rock type can go through weathering and erosion, which means they turn into sediments. And every rock can do heat and or pressure and metamorphism. Basically, what this is saying is any rock can turn into any other rock. One thing I do want to point out, I'm going to ask you this. How can a sedimentary rock turn into an igneous rock?
It would have to.
Wait, let me ask again, just in case people weren't. How can a sedimentary rock turn into an igneous rock? Melt, magma, solidification. What I want to point out is, does a sedimentary rock have to be a metamorphic rock before it turns into an igneous rock? Right. It does not have to go around the outside of this circle. There's plenty of shortcuts in the middle, and rocks do not take the long way around. They always go from one directly to the other. You don't have to go around the whole circle. Like I was saying earlier, we are going to start learning a little bit about igneous rocks today. There is a reading here on page 12, and yeah, we are going to read page 12, but not just to get information. And actually, we're only going to read the top half. We're not going to read about texture. But there's a reason for the reading. And that reading, the reason for the reading are going to be these 4 things that I want to make sure you know about igneous rocks. So first of all, there's two types, intrusive and extrusive. And they are very different in their environment of formation. Does anybody know what I mean by environment of formation? Okay, could be a volcano. It is where they form. Yeah, one might be a volcano. So where they form. For how they formed, I'm looking for how fast they cool. Because all igneous rocks come from hot magma. They cool differently. Physical properties, I am just looking for what they look like. And I think example is pretty self-explanatory. Okay, so for each type, there's two types, intrusive and extrusive. I want to know where they formed, how fast they cool, what they look like, and at least give me one example of each. Do you want to go through the reading together or do you want to read it on your own? Together. Okay, if you want to do it on your own, you don't have to listen, but I'm going to read it out loud for you. Again, you're looking for where, how, what they look like, and an example of each. So it says the term igneous comes from the Latin ignis, meaning fire. Igneous is used to describe rocks that crystallize out of hot, molten material in the earth called magma. When magma pushes up through the earth's crust to the surface, it's called lava. Both magma and lava solidify or harden to form igneous rocks. Igneous rocks can be classified into two main categories, intrusive and extrusive. A trick to help kids remember intrusive and extrusive is to think intrusive, inside, and extrusive, exit. Intrusive rocks come from magma. They cool slowly deep in Earth's crust. When the magma cools underground, the crust acts like a blanket, insulating it, keeping it warm longer. Because magma cools slowly, crystals of different minerals have time to grow. The molecules in the magma have time to arrange themselves into crystal formations before the magma hardens. The intrusive rocks have large crystals that can be seen with the naked eye. A common example of an intrusive igneous rock is granite. Extrusive rocks come from lava. Lava at the surface is exposed to air and water, which causes the molten rock to cool rapidly. Solidifying rocks at the surface cool too quickly for large crystals to form. Molecules in the lava do not have time to arrange themselves to form large crystals. Extrusive rocks have crystals that are too small to be seen without magnification. A common example of an extrusive igneous rock is basalt. Some extrusive rocks, such as obsidian and pumice, cool so rapidly they completely lack crystal structure and are considered volcanic glass. Pumice is just like obsidian, except for tiny shards of glass. I think from that reading, you should have been able to gather all of this information. Did you find where intrusive rocks form? So they form inside Earth or underground. Because they form inside the earth and underground, how fast do they cool? They cool slowly. Basically the layers of earth on top of them act like a blanket, just like when you use a blanket, you stay warmer longer than if you didn't have a blanket. Because they cool so slowly, what happens? They have large crystals that you can see without using any tools. And what was the example they gave? Granite. Just like a granite countertop, that's the granite we're talking about. Large, visible crystals. The way that the reading reminded you to remember is that intrusive form inside Earth. Now the opposite is extrusive. Where do they form? On Earth's surface. I like to remember they form on the exterior of the Earth, or they have exited Earth, and that's where the X comes from. Extrusive, exterior, exit, any of that. Because they're on the Earth's surface and it's cold out there in the air and the water. How fast do they cool? Very fast or rapidly. Because they form so fast, how do they look? Small, or what else did it say? Not only not visible, but it said that sometimes they cool so rapidly that no crystal structures can form. So small or no crystals. And they gave several examples. You only needed one, but give me a couple of them. Okay, so one was basalt, obsidian, and pumice, I believe, are the three. Oops, not pumpkins. Pumice. We're going to go into more detail on igneous rocks tomorrow. You do have a little bit of homework. It's on page 11. There are 5 questions. You have a couple minutes. You might be able to get through page 11 now. If not, it's 5 questions. Actually read them, actually try them. It won't even take you 5 minutes. And remember, you have a quiz on Thursday.